We have another great lecture plan for you today. We're meeting after a week, right? हम last Thursday मिले थे. Okay. Schedule हमारा change हो गया. We meet on Thursdays and Fridays now. Friday our class is on 2:30 instead of 1 p.m. Okay. Okay. So let's start. I have a reminder for you regarding the rules of the game. You're going to call me Dr. Mudassir, professor or just doctor. Okay. You're not going to call me sir. You're going to turn off your phones. I assume everyone has already turned off their cell phones. Please do if you haven't. You will be on time and you will not enter the classroom if you are more than 5 minutes late, okay? Otherwise, you will be penalized. You won't talk to each other, you will talk to me. And you will be honest and you will be courteous in class, okay? Practically, all I'm asking you guys to do is to be treated as adults, okay? In the sense that वो hand holding नहीं होगी, and I'll respect you as adults too, okay? And I want the same from you guys, okay? Cool. Okay, so don't be daunted by this slide or these rules. थोड़ा सा leeway मैं आपको दे सकता हूँ. The leeway is in the form of कि अगर आप इस क्लास में आते हैं and you spend 5 minutes and then you decide कि बोरिंग हो रहा है क्लास में ना, कुछ भी नहीं समझ आ रहा या सब कुछ समझ आ रहा है और मुझे क्लास अटेंड करने की कोई ज़रूरत नहीं है, तो then I allow you कि आप अटेंडेंस लगाएं और you walk away from the class, okay? You won't be entered back again because of the hour policy, but that's allowed and it does not hurt me or it does not bother me, okay? That's fine. For a class that you think उसमें से आपको कुछ नहीं मिल रहा, तो that's perfectly fine. एक और चीज़ जो allowed है वो ये है कि you can go to the farthest seat from here and you can go sleep there, okay? That's also allowed. Just don't snore, don't make noises that disturb the people around you. That's also absolutely perfect and fine here, okay? जो चीज़ allowed नहीं है वो ये है कि आप क्लास में आए ही ना, okay? I need at least 5 minutes of your time to convince you that what I'm gonna tell you is worth your time, okay? वो 5 minute you have to give me. वो 5 minute नहीं देंगे तो you didn't even give me a chance to convince you कि जो मैं आपसे बात करने जा रहा हूँ वो worth your time है, okay? So you'll give me 5 minutes. और उसके बाद आपको लगता है कि it's not worth my time, so you're perfectly fine and okay to leave the class, okay? All good? All right. So these are the rules of game. Last time मैंने okay, yeah, we should have done it this last week, but here is the thing that you need to do by end of day today. You're going to make a group of 4 to 6 people, every one of you. Minimum size of group is 4, maximum size is 6. This is a group for group activity. If you remember, group activity we'll have 4 group activities once, probably a month. जिसमें you will get together with your group and you will discuss something regarding discrete math, and the whole session will be recorded, okay? उसका time lapse करके आप मुझे 1 मिनट की summary भी देंगे, okay? The whole session will be recorded, जिसमें आप बैठे हुए हैं कहीं पे भी, ITU में या किसी कैफ़े में या 3rd floor पे, wherever you need to be, but everyone needs to be present there. It cannot be on Zoom or वो नहीं होगा, physically you need to be there, okay? तो उसके लिए आपने एक ग्रुप बनाना है, एक और ग्रुप आपने बनाना है शो एंड टेल के लिए, okay? This time we are going to have a few presentations. 3 sessions होंगे हमारे और हर सेशन में we'll have about 3 to 4 or 5 presentations, जिसमें आप आएंगे and you'll talk about anything. We'll give you some topics, but you can talk about anything discrete, okay? तो उसके लिए आपने एक ग्रुप बनाना है that also needs to be in the interval 4 to 6, okay? ये जो आपके 2 groups होंगे, they need to be somewhat disjoint in the sense कि you can have 2 people common in 2 groups, but not more than 2, okay? So if you have a group of 5 people, same 5 people cannot make the group for show and tell, okay? To make a group for show and tell, you'll have to find new people, okay? And that's part of your training as kind of college students now, to be able to talk to other people, okay? To work in team. Any questions? Good? All right. Here is a list of things that we are going to do over the course of our class or fall term. And these are our learning objectives, okay? This is the kind of cliche term. Here's where we are right now. This is where we are starting. We're trying to understand and translate propositions, okay? कुछ English में लिखी हुई हैं, कुछ math form में लिखी हुई हैं. We should be able to translate them, understand them. There's something called predicates जो हम पढ़ेंगे. There's something called quantifiers. ये हम करेंगे. और उसके बाद there are a bunch of other things. This is also logic, second part. उसके बाद there's something called relations जो हम पढ़ेंगे. Functions पढ़ेंगे. उसके बाद computation पढ़ेंगे हम. Okay, there is some problem with the projector. All right, we'll study recurrences, we'll study inductive proofs, or last we'll talk about counting in graphs. Okay, these are our learning objectives जो हमने करने हैं. And as we go along, और हम एक कर लेते हैं, तो we'll strike it down कि ये हमने कर लिया, and we are moving on to the next step. Okay, so we are starting here. We are talking about propositions and their translations. All right. All right, so here's where we were last time. We were talking about conditional propositions. Before conditional propositions, we talked about just propositions. We said propositions are statements that have a truth value. Okay, they are either true or false. We may not know whether they are true or false, but they must have a unique truth value. Okay. फिर इसके बाद हमने ये कहा कि we can take two different propositions and we can combine them, okay? And to combine them, you need operators, okay? We saw AND or conjunction operator. We saw or disjunction operator. What else did we see? Negation operator. What else? Exclusive or, and what else? Biconditional. And conditional. Conditional is also an operator, right? You take two different propositions and you condition them. You say if P, then Q, okay? Biconditional was the last thing we saw. Yeah, we moved on from here, okay? We saw what trivially true statements were. We saw what vacuously true statements were. Last row, people in the last row, what's the difference between vacuously true statement and trivially true statements? Yeah?
Sir, in trivially true statement.
What did you call me?
Professor.
Yeah.
If in the trivially true statement,
Yeah.
If the conclusion is true,
Yes.
then the condition is also true.
Yeah.
But then in the vacuously true statement,
Yeah.
if the hypothesis is true, false, I'm sorry.
Yeah.
If the hypothesis is false, then the condition is also true.
Absolutely, yeah. So trivially true statements are the statements where conclusion is true, regardless के hypothesis true है या नहीं है. उस case में the statement is trivially true. Okay, and vacuously true statements are where your hypothesis is false, regardless के conclusion true है या नहीं है. We don't care about that. The statement is going to be true. Okay, good. Thank you. We saw equivalences. Okay, so how do we find equivalences of two statements? What we do is we construct their truth tables. Okay, if their truth tables are equal, they must be equivalent. We saw a few ways to say if P then Q and sufficient and necessary. We saw what con was, contrapositive and inverse was, and we saw biconditional. That's, I think, where we were. All right, so two propositions are logically equivalent if they have the same truth table for every possible combination of truth values of their variables. Okay, so a compound proposition is constructed by multiple propositions. उन propositions को हम variables कहते हैं. Okay, P and Q are our variables. Okay, so two compound proposition would be equivalent if their truth tables last column look exactly the same. So if P is it's raining and Q is I need an umbrella, the logically equivalent they're logically equivalent because whenever it's raining, I need an umbrella, and whenever I don't need an umbrella, it's not raining. Okay. Okay, this is a bit tricky. That's a bit tricky. I think there is something wrong here. So if P then Q seems true, but if Q then P does not seem true. Okay. So this is wrong. In my view, this is not. These two statements are not equivalent. Okay. All right. But these two statements are equivalent. Do you recognize what this is? This is contrapositive. Okay. In contrapositive, what you do is you negate two statements and then you search them. Okay. And we saw last time that this is actually equivalent to the original statement. Okay. But here are their truth tables. If you make their truth table, you will see that you will get exactly the same thing, which is T, F, T, 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 F, T, T. Okay. Awesome. So we conclude that statement is equivalent to its contrapositive. I hope this is clear to everyone. If you have any questions, ask me. Now is the time. Okay. That's cool. How about this? Is it true that converse propositions are equivalent to inverse propositions?
Yes.
Yeah, we actually answered that last time that this is the case. And if I ask you why this is true, what you would have to do is you would have to construct their truth tables. Okay. In a moment, we'll see another way to find whether two statements are equivalent or not. But in exam, if I say that find whether two propositions are equivalent or not, then you're free to find any method you want. Okay, you can draw truth tables, and we'll see a substitution method. You can use that as well. But if I say do it by truth table, then you'll have to construct truth tables. Okay. How about this one? What's your guess? So you know the truth table of if P then Q, right? If P then Q is only only false when your hypothesis is false and your conclusion is true, right? You negate it, and then you find out the truth table for this one. I think I have the truth table here. So this is the truth table for P and not Q. If you look carefully, this is exactly the negation of if P then Q. Okay, P then Q was only false here. Everywhere else, this was true. Okay, so these two statements are equivalent because their truth tables are the same. So the way you do it, you find the truth table for the first one. This would be your step one. You find the truth table for the second statement. And then you conclude that the last column of both of these truth tables are equal. Okay, so you do these three steps to conclude the statement is equivalent or not. Okay, I'm just trying to give you a systematic way to do this. All right, a proposition that is always true, regardless of truth values of its variables, is called a tautology. Okay, here's an example. P or not P is always true. Okay, regardless के P true है या नहीं है. Okay, so P or not P is a tautology. Okay, and you can see by constructing its truth table. If you construct the truth table, the last column will always have T's in there. Okay, regardless के उसके variables की values क्या हैं. Alright, so this is a tautology. A tautology is a statement which is always true. We have a similar statement which is always false. It's called a contradiction. Okay, a statement that is always false is called a contradiction. Negation of a tautology is a contradiction. Okay, P and not P is always a contradiction, regardless के P true है या नहीं है. Are we on the same page? Yes.
Yes.
Okay. If T is a tautology and C is a contradiction, what are the truth values of P and T and P and C? Raise hands. You have something to say? Hello, talking to you, yeah. Yeah.
Sir, Professor, the first one is always true, and the second one, tautology, or you can say the second one is all false.
No, pay more attention. P and T.
So one false, one true, Professor, one false, one true, and the last one false.
So again, once P and T, what would P and T would be?
One false and one true. If there are two conditions, right?
When would it be false and when would it be true?
When both are true, it would be true. When A is false, it would be false.
And another way, what we are saying is
It depends on P.
it's equal to P, right? Okay, so P and T is equal to P. Okay, P conjuncted with a tautology is always the P itself. All right, how about this one? P and a contradiction.
Always false.
P and C is always false. Good. Are we on the same page? Yes?
Yes.
Okay. Can you see, you guys, can you see this? Can you see this? Is it fine? Okay, good. Nice vision. All right, P and T is equivalent to P for every value of P, since it's T is always true. P and C is always false. Is the following statement true? So the thing is, the point I'm trying to make here is that to prove that this statement is true or not, what you're going to have to do is construct its truth table. Okay? To construct truth table of this thing would be kind of a nightmare, right? Because you would have to, construct truth table of this part, then this part, then negation of this part, and then this part, and then this part, right? You can't probably do it on one page. So we need new, more modern technology to find the equivalences of statement. Okay, and here's one of them. It's called substitution. So far we have used truth tables. It's not the easiest way to find truth value of complex propositions. So what we do is that we substitute parts of the proposition with something that we already know. Okay, so for example, if we have P and T, where T is a tautology, we can replace it with just P. Okay, so इस तरह की substitution के we have a bunch of rules that we can reuse when we are trying to find out tautology or contradiction of a proposition, okay, or equivalences of two different statements. Make sense? Are we good? Okay. So here's an example. Afra went skiing and she broke her ankle. Afra is, by the way, my wife. Okay. What's the negation of the above statement? So essentially you have statement like this, right? P and Q, and you want to negate the whole thing. What do you think would be the negation of this statement? Afra went skiing and she broke her ankle. Yeah.
Didn't went skiing and she didn't broke her ankle.
No. So what he said is Afra didn't go skiing and she didn't break her ankle. Okay? That's not the negation of this statement.
Afra didn't went skiing or broke her ankle.
How about?
Afra didn't go skiing and broke her ankle.
No. So again, exact words आपके ठीक नहीं है इसकी जो negation है. Let's see what this is. Okay, इसको process करते हैं इस statement को. Okay, so above statement is true when both P and Q are true. Okay, when both of these statements happen, those case में we'll say that this statement is true, right? We want negation of that. Okay, so if P is false or Q is false, this statement would be false. Okay, that would be the case when the statement is false. Make sense? Let me repeat. This statement is true when both variables are true. Okay? If at least one of these variables is false, this statement would be false. Okay? So the negation of this statement is that at least one of these variables is false. Okay? And how do you say that at least one of these statements is false? You put an R between them. You disjunct them. Okay? You negate the two things, and then you put an R between them. Okay? Are we on the same page? Does it make sense? So the negation of Afra went skiing and she broke her ankle is Afra didn't go skiing, or if she went, she didn't break her ankle. Okay? So that's the negation. यहाँ पे आप and लगा देंगे तो भी ये negation नहीं होगा. यहाँ पे आप didn't कहीं पे miss कर जाएंगे तो भी ये negation नहीं होगा उसका. Okay? So the negation of P and Q is negation of P or negation of Q. Does this remind you of anything? Yeah, it's the De Morgan's law of logic. First, De Morgan's law of logic. It helps you if you have a statement, compound statement, and you need to take the negation of that compound thing. It helps you resolve that. Okay? So the negation of P and Q is negation of the two statements disjuncted. Okay? It's the disjunction of two negated parts. And the negation of P or Q is conjunction of their negations. Okay? Make sense? All right. Cool. We're waiting for this thing to work. But here's the kind of not exhaustive but a long list of laws which should be let's process them one at a time. Okay? By the way, there are errors here. Okay? So if you find an error here, and let me know before I come to that error. I'm going to give you, we have a worksheet today, Hannah? I'm going to give you 2 points on worksheet. Okay, so it's 10 points thing. If you'll get 2 extra points for it. Okay, if you figure out the error before I come to the error. Okay, raise hand, don't shout. Okay, raise hands and let me know. You figured out the error?
Sir, De Morgan's law the first.
De Morgan's law का कौन सा part? Oh, this part. Oh, you are good. You are good. What's your name? इनका नाम ले लें. ठीक है? उनसे अब ID बता दें इनको. Okay? So she figured out the error. She gonna get 2 extra points on her first worksheet. क्या?
So double negation.
Oh, double negation. Where is it? Over here. Negation of the negation is equivalent to negation of P. We are right. Yeah, this is also false. Who do I pick? Go ahead.
P and F is equal to
Which one?
identity law.
Identity mein you are saying that P and F is P. This is also wrong. Yeah, you are right. Wow, I thought I made fewer mistakes than I did. Any other mistakes?
So negation, professor negation of negation.
ये हो गया. Someone already did it. Okay, I guess there are only 3 errors there, but we'll see if there are more. All right, let's see this. The first one is commutative law, which says that P or Q, there's another one. You cannot get 4 points. You can only get 2 points, okay? All right, for this quiz, okay? Right, commutative law says that there's no order between conjuncted or disjuncted statements. Okay, P or Q is same as Q or P. P and Q is same as Q and P. Okay, so that's what the commutative law says. There's no order. Associative law says that if you have the same operation, then you can put the parenthesis wherever you want. Okay, if you have P, Q, R and you have same operation, disjunction है दोनों जगहों पे, तो फिर you can replace the parenthesis. पहले P और Q कर लें या पहले Q और कर लें, whichever you want. That's fine. Okay, as long as it's the same operation. अगर operation different होगा तो we'll have a distributive law for that. Okay, make sense? Are we good? You seem lost. Are we good? Okay, cool. Distributive law says that if it's not the same operation, then the operation outside distributes. Okay, so ये distribute हो रहा है यहाँ पे कि ये वाला और वाला जो part है ना, this is going to be at both points now. Okay, distribute हो रहा है, दो बन रहे हैं उसके. So P would be disjuncted with Q and P would be disjuncted with R. Okay, we'll distribute disjunction here, or इस case में we will distribute conjunction here. P would be conjuncted with Q or P would be conjuncted with OR. Okay, so that's distributive law. So again, the essence is that whenever you see a statement of one end of this law, you should be able to figure out what should be the other end. Okay, it should not be memorize करें इसको. It should be kind of instinctively in your brain that this is equivalent to this. We saw De Morgan's conditional says that if P then Q is equivalent to negation of P or Q. Okay, can anyone kind of explain why this is true? Why this makes sense? Why this conditional law makes sense? We have kind of in words talked about it. If you remember, I told you what Weckers-Leto statement is, right? What is a Weckers-Leto statement?
With the hypothesis is false.
With the hypothesis is false. Okay, so this is ये वाला जो part है ना, पहला part. This is when the hypothesis is false, है ना? So this is saying that when hypothesis is false, you have P. If P then Q is true. And the second part says when the conclusion is true, you have if P then Q. Okay, so this is just negation of P is the case when your statement is Weckers-Leto true, or Q when your statement is trivially true. Okay, there are two ways to have your statement. Have a conditional statement true. Okay, and these are the two parts. Okay, I hope everyone can see this. Yeah. Sorry, what? I'll come to it. Just a moment. You're saying that this is wrong? So someone already claimed it. Okay. Sorry, but yeah, you're right. Good to spot it. All right. Negation of this thing would be negation of this thing, which is we already know by the De Morgan's law. Okay. You would have to negate P, and the negation of P is just P. Okay. And you would have to negate Q, which is here, and you would have to negate the preterm. Okay. Awesome. Biconditional says that it's just the definition of biconditional. Okay. P biconditional Q is just if P then Q, and if Q then P. This is the definition of it. Identity law is wrong here. It should be that P and false should be false. Okay, या फिर ऐसा होना चाहिए कि P और F should be P. Okay, किसी contradiction के साथ आप disjunction करेंगे किसी statement को तो you'll get that statement. Okay. Domination says that P dominates tautology when you are doing disjunction, and F dominates. Oh, hold on a second. This one is wrong. You guys didn't figure out this one.
You said not to tell you.
Sorry, what?
You told me not to tell you the Rakan.
Oh, okay. Okay, you already got 2 points for it, but yeah, you're right. So this one is wrong as well. Over here you want conjunction. Okay? If you have P conjuncted with a contradiction, you would get a contradiction. Okay? Because this part is always false, right? किसी statement को किसी false statement के साथ आप end करेंगे तो you would definitely get a false, right? For conjunction you need both parts to be true. Awesome. Double negation is, it should be just P. Idempotent says that if you disjunct a statement twice, you get the same statement. If you conjunct the same statement twice, you get the same statement. Okay? Cool. You're going to have to use these laws to find equivalences of statements. Okay? Here's the corrected version of, I think, all of them. Is everything corrected here? Last time मुझे याद है यहाँ पे correct version में भी कुछ गलती थी. I don't know if I corrected it. Yeah, I think things look fine. Yeah. Okay. So truth table के साथ तो आप कर सकते हैं इसका, but logically you should also be able to see why these are true. Okay. Yeah. And practice, I guess. Okay. Okay, so see, the first law says that when you have disjunction between two statements or conjunction, unka order matter nahi karta. But when you are evaluating a complex statement, the order matters. कि कौन सा part आप पहले evaluate करें. Okay, you'll have to evaluate. सबसे पहले आपको क्या evaluate करना पड़ेगा? Whatever is in the parenthesis. Okay, और उसके बाद negations, और उसके बाद conjunction and so on. Okay. Nice. All right, let's see an example. So we want to prove this. All right, so let's start with the left hand side. Okay, so this is what we have on the left side. What do we do? What is the first law that we can use here? Remember, आप हम truth tables की domain से निकल आए हैं. Okay, we don't need truth tables anymore. Okay, we're trying to figure out. हम कहेंगे कि this statement is equivalent to another statement because of this law. Okay, we know these laws. I'm going to apply this law and now I'm going to get this statement. उसके बाद I'm going to apply another law or maybe same law again. Right? I'll keep doing it until I reach the right hand side. Okay, that's our goal. जिसमें हम prove करेंगे कि ये equivalent है या हम ये prove करेंगे ये equivalent नहीं है. Okay, we'll reach at a point, we'll see कि where one of them is true and the other one is false, obviously. Okay, so what should be the first law that we apply on the left hand side? Yes. जोर से बोलो. Contradiction. What was contradiction law? There is no contradiction law. These are the laws that are available to you. Pick one law and tell me, okay, I'm going to apply this. Okay? Distributive law. Someone said conditional. You are saying conditional. You're saying conditional. Anyone else? Okay, let's go to a statement. I see why you are going the way you are going. Apart from conditional मुझे यहाँ पे नहीं समझ आ रहा क्योंकि this one is not negated. I mean, you can apply it. It's there is no harm. But you know, when I look at this, I see a different law. Sorry? Yeah, I see De Morgan's law. I see a De Morgan's law. So what's happening is I see two statements which are disjuncted, and then there is negation outside. Okay. You can definitely apply distributive law and go from here. That will give you the same answer. Okay. But at times you have options to apply two different laws. Which one do you apply is just your gut feeling. Okay. You apply one, try it. अगर कहीं पे जाके फंस गए तो you come back to that step and you apply a different law on that step. Okay. इस case में it doesn't matter which one you apply. Both will lead you to the right answer. Okay. But at times they may not. At times they will get you some. They'll get you stuck in some alley. Okay. Then you come back, backtrack, and then see कि मैंने कहाँ पे वो choice की थी. So I'm gonna make a different choice now. Okay. So if I apply De Morgan's. Do I apply De Morgan's? Yeah, I apply De Morgan's. So I would get negation of P. I would change the operator, and I would get negation of the second part. Okay. This. उसके बाद फिर I'm applying De Morgan's law again. Okay. ये वाले part के ऊपर. So what I want you guys to do is every time you apply a law, you write down the name of that law. Okay. So over here I wrote the law. यहाँ पे मैंने नहीं लिखा, but I should have. Okay. So if I apply the De Morgan's law again, I would get this. What should I do now? At this point, I have to apply distributive law. Okay? यहाँ पे मुझे कुछ और नज़र नहीं आ रहा डिस्ट्रीब्यूटेड के अलावा जो हम कह सकें. So what happens is कि negation of P and would be distributed on these two things. So I would get boy, I kind of gave you 2 steps ahead. Yeah, so this becomes negation of P and P, and negation of P and P is a contradiction. Okay, and you would get negation of P and negation of Q, which gives you this, and contradiction or some statement is that statement. Okay, so you get this. This is it. So we understand every step of the way. Alright, so let me just give you the laws that apply. I applied distributed law. Sorry, I applied De Morgan's, then I applied De Morgan's again, then I applied distributed, and then I applied the identity. Okay, these are the. I also applied idempotent at some point, right? Did I? No, I had P or not P. Where is that? Okay, that's not here. That's the definition of contradiction. Okay, P and not P is a contradiction. Okay, so you just write by definition of contradiction. All right, these are the few laws that I applied. In that order, I applied De Morgan's, then distributed, then definition of contradiction, and then identity. Okay, and this gives me the right hand side. At this point, I would write QED, or I would say this is what we were supposed to prove. Okay, are we good? Do you feel confident that you should be able to do this? Okay. All right. How much time do I have? I have some time. So here's the summary of proposition logic that we have seen so far. We introduced the concepts of proposition logic, logical operators, truth values. We saw a few operators. We saw how to construct truth tables and how to find out whether two statements are equivalent or not using truth tables, and also by using the laws of logic. Okay, जो हमने अभी देखे हैं. I think this is the end of this deck. Let me pull out a new set of slides, which will take a moment. Moving away from the proposition logic. There are limitations of proposition logic. It's adequate for to handling statements that where we want to quantify things. Okay, if there is a statement that we want to say about, for example, everyone in this class or someone in this class, the propositional logic is not adequate. What I would have to do is I would list people, or her bande ke liye I will have to make a different statement. Okay, so that's the kind of one problem with the propositional logic. The statement must be repeated. For example, if Alice is a CS graduate, then she knows logic. If Bob is a CS graduate, then he knows logic. If Charlie is a CS graduate, then he knows logic. Okay, there's no way to say all these statements in just one statement. Okay, condition on the fact कि कुछ आपकी domain के अंदर कुछ लोग CS graduate हो सकते हैं और कुछ लोग CS graduate नहीं हो सकते हैं. Okay, so we escape from the limitations of propositional logic and we go to something called predicate logic. Okay. So predicate logic we have explicit models for objects and their properties, and it allows us to have statements where we have variables and quantifiers. Okay, variables हमने पहले भी रखे थे, but more important part is quantifier. We will be able to quantify the variables. Okay, for example, we can have constants, building blocks, right? We can have someone's name, we can have some artwork, a date or something. We can have variables which specify something in some domain. Okay, a domain is a collection of unordered collection of things, and a variable would say, okay, anything about, I'm talking about something in this domain, so I'll use a variable for that. Okay. Predicates are the kind of used to relate things. Okay, they express the properties of objects that connect one or two variables. Okay, or one variable and a one constant, and so on. We'll see how that works. So, for example, do I have a statement? Yeah. So these are the variables. X, Y are, for example, the variables. Predicates are operations on those variables which connect those variables. For example, when I say orbits x, y, what I'm trying to say is that x orbits y. Okay? It's leap year, x is a variable, so it's leap year is saying that x is a leap year. Painted, Leonardo, Mona Lisa. Leonardo painted Mona Lisa. Okay? So that's the predicate logic. Okay, consider that the following predicate logic statement. P of x where x is a prime number. Okay? Up, is this thing a proposition? Do I ask this question? Let me come back. Okay? So in the next statement we have a statement which says that P of x, just P of x, but what it means is that x is a prime number. Is this a proposition?
Yes.
Should we do a vote? Let's do a vote. People who say yes. Aye. Alright, so is it true or false?
It could only be true or false if you put a value. That makes it false, I guess. That doesn't make it a problem.
Yeah. No one can tell you the truth value of P of x. Right? Because x is an unknown thing. Which means that P of x is not a proposition. Okay? It's not a proposition. For a proposition, you must have a truth or false value. You may not know it, but you must have a truth or false value for it. Okay? There is no truth or false value for P of x until someone tells you x. Okay? Cool. So P of x is actually not a proposition. Okay? It's called a propositional function. It's a function. Okay? So, but these things, यहाँ पे जब मैंने x specify कर दिया, these things are propositions now. Okay? Now we have propositions. All these 6 things are propositions. They may be true or false, but all of them are propositions. Okay? क्योंकि अब मैंने variable को किसी constant के साथ replace कर दिया. P of 2 is of course true. P of 6 is false. P of 4 is false. Everything else is true. Right? But all of these 6 things are propositions. P of x is not a proposition. Okay? Keep that in mind. Let's not make that mistake ever again. Okay? Are we good? Let's move on. Cool. Let's represent the statement students missed breakfast. Okay? We can use a predicate m of x to denote that x missed breakfast and x represents the student. Okay? Whenever you write a predicate or a propositional formula for each variable, I want you to specify the domain of that variable. Okay? उस किस domain से वो variable अपनी values ले रहा है. यहाँ पे x की domain is the students in this class. Okay? Students in this class is the set जिसमें से x values ले रहा है. Okay? M of x is my predicate or propositional formula. For how many of you this is true? Okay. Awesome. These are healthy guys. Okay. हमारी मेरे ख्याल में क्लास सुबह 9 बजे होती थी इसलिए लोग मिस करके आते थे. Last time I asked this question, almost everyone had their hand raised. But today I like 5 people and 4 people. Anyhow, okay, good. Breakfasts are good. Don't miss it. Cool. So this is a predicate formula. X is a variable representing a student. M of x is a predicate indicating that x missed breakfast. This way we can express the statement student missed a breakfast in a predicate logic. Okay? Okay. Here's another one. So predicate q, x, y, z denotes the statement that x square plus y square is equal to z square. अब यहाँ पे एक गलती की है मैंने स्लाइड पे. What's the mistake that I made here? What's the mistake on this slide? I'm saying that qxyz is a predicate, okay? Or a propositional formula. What's the mistake that I made here? Girls only. Girls only. What's the mistake here?
Domain is missing.
Domain is missing. Domain of x, y, z is missing. I did not specify कि x कहाँ से आ रहा है, y कहाँ से आ रहा है, or the integers, positive integers, non-negative integers, real numbers, rationals. वो specify नहीं हुआ हुआ यहाँ पे. Okay? Good point. Okay, x, y, z. Okay, for now let's assume that their domain is integers. Okay. What's the truth value of q 3, 4, 5? Q of 3, 4, 5 is true. What's the truth value of q 2, 2, 3? Q 2, 2, 3 is false, right? Because 2 square plus 2 square is not 3 square. How many values of x, y, z make the predicate true? Yeah. How many values? How many values of, assume x, y, z की जो domain है, that's integers, okay? For how many values this is true? Infinite. Infinite. There are infinitely many values of x, y, z for which this is true. And these are known as the Pythagoras triples, okay? For all values of x, y, z for which you can make a triangle, right triangle, this you would get, for those x, y, z, you would get this formula to be true. Okay, you can make you have a triangle, you stretch it, you get another triangle, you stretch it a little bit more, you'll get another triangle. So you can get infinitely many such triangles, which means you can get infinitely many such triples. Okay, cool. This is kind of a so the point I'm trying to make here is that when you say that there are infinitely many triples for which this thing is true, you need to be able to come up with an argument which convinces someone why this is true. Either you iterate everything in the integers, okay? या फिर आपको you will have to give a logical proof of it. I gave you a logical proof of it why this is true. What I told you is that if you take a right triangle, for that right triangle you have 3 values for which this is true. Now I can stretch that triangle a bit more and I'll get new triple. And I'll keep doing it and I can do it infinitely many times, which means that I can get infinitely many triples for which this is true. Okay? Make sense? There are going to be statements which are absolutely obviously true, but you're going to have to give me a reason why they are true. Until you give me that reason, your answer won't be accepted in this class. Okay? All right. So how many right triangles are there? There are infinitely many right triangles, so there are infinitely many triples there. I'll stop in 5 minutes, I guess. Then we will have a worksheet for you. Okay. Quantifiers. This is the magic that makes predicate logic kind of infinitely fun. Okay. So a predicate can become a proposition when we assign constants to the variables, है ना? हमने अभी तक देखा है. But there is a more fun way to make it a proposition, and that's by quantifiers. There are 2 quantifiers. One of them is the universal quantifier. The other one is existential quantifier. Have you guys seen these things before? Yes. Everyone has seen these things before? Yes? No? Yes. People who have not seen these things before. Okay, why is it that some of you have seen them? Where did you see it? In your high school books or something? Yes. Oh, okay. Why haven't you seen them? They were not in your books? Oh, okay, cool. All right. Well, we are equal today. Okay, so we'll explain everything here. So I kind of don't rely on any of your background knowledge. Okay, so I don't expect to know anything I'm telling you. Okay, I have an expectation on infinite intelligence on each of yours part, but I don't have any expectation on any background that you might have. Okay? So if you don't know anything on my slides, that is obvious to everyone else in the class, do raise your hand. Okay? And I'll be proud of you if you ask the question, okay, I don't know what this is. Okay? Cool. So we say, we universally quantify a predicate when we want to say the statement is true for everyone in the domain. Okay? So we say for all x, p of x. A moment ago I gave you the example of students missed the breakfast. Okay? When I want to say that everyone in this class missed the breakfast, what I would say is that for all x, m of x. Okay? But when we have the situation that some of the people missed the breakfast, but some of them did not, what we would do is we would use the existential quantifier. We would say that there exists x m of x, that there is at least one person in this domain for which m of x is true. Okay? How are we going to say that none of the students missed the breakfast? What? Universally quantify, and then what? We'll see that in a moment. Okay? But I just want to keep this question in the back of your mind. Okay? This is a valid statement that we use in the class. How are we going to say this? Okay.
For all m of x is false.
Yeah, that's just true. Good. But we'll come back to it. Okay? Universal quantifier is like a magic spell that makes statement apply to every member of the set or domain. But remember, अभी हमने थोड़ी देर पहले एक example देखी which was q of x, y, z. Okay? You have 3 variables. You would have 3 different domains. If you want to make this a proposition, you would have to quantify all 3 variables. Okay? If you quantify one of them but don't quantify 2 of them, it's not a proposition. Okay? You would have to say that for all x, for all y, there exists a z, or something like that. You'll have to quantify all 3 of them to make a proposition that has a truth value. Okay? I'm kind of stopping on this slide because I think this is very important. हम यहाँ से next time, which is tomorrow, we'll start करते हैं. अभी I want you to stay wherever you are. Find a buddy to the left or right, and we're going to give you a worksheet which you are going to do in pairs. Okay? So both of you will discuss कि उसको कैसे करना है. आप अपना रोल नंबर लिखेंगे दोनों, और आप एक आंसर शीट हमें रिटर्न करेंगे. Okay? I'm also, think of me as, or these guys as the third member of your group. Okay? So if you get stuck somewhere, raise hands, I will come to you. Okay? Find a buddy to the left or right. Thank you guys. I'll see you tomorrow.